Hello and welcome to Algebra 2, Chapter 5.7, Graphing and Solving Quadratic Inequalities. So we're going to get out of the equations and into inequalities for a section. So to graph an inequality is very similar to graphing an equation. We're going to go ahead and we're going to graph it just like we did before using our axis of symmetry and our vertex. You might use your intercepts, you might choose a table. So you're going to graph it how you did before, but then remember if there's an inequality, that means that the answer is a region, and so we need to then shade that region, and so we're going to pick a test point, check it in the original inequality, and make sure that we shade the appropriate region for the answer. So either shading inside the parabola or outside the parabola. So our first one, y is less than or equal to 2x squared minus 5x minus 3. And I would consider it just as an equation for graphing purposes. So you can think of your inequality just as an equal sign. And if I want to graph this, the first thing I'm going to use is my axis of symmetry. And it's a negative 5, that's what my b is, over 2 times 2, which is a positive 5/4. Okay, so that's 1 1/4, and so my table then I would start at 5/4, and then I'm going to put 5/4 back into my equation, and so I'm going to do 2 times 5/4 squared minus 5 times 5/4 minus 3. I'm going to get negative 2, 6 1/8. So when I graph that, I'm going to go over 1 1/4 and down 6 1/8, something around there. Then I might come back and do 1 and 0, and then do 2 and 3. These are not going to be symmetric because my axis of symmetry is not halfway in the middle, so I need to actually figure out what these are going to be. So I get negative 6 for 1, so 1 negative 6, and then if I change those to be zeros, I'm going to get a negative 3. So 0, negative 3. So all I'm doing is plugging these x's into my equation, and then I'm going to put in a 2. Oops, 2. And that's a negative 5. So notice it's not symmetric, but that's okay. I anticipated that. Okay, because this vertex down here is not halfway between. And so this would be another good reason why you just don't always assume what your other numbers are. 3, I get 0. Okay, and this is going to just be a regular solid parabola. So there's my parabola. So the first step, just graph it like you did in 5.1, and if you need to look back to 5.1 to figure out how to graph it, that's fine. So the next step is I need to shade, and so either I'm going to shade inside my parabola or I'm going to shade outside my parabola. And so what you want to do is you want to pick a test point, and so I'm going to go ahead and I'm just going to pick 1, 0. I mean, you want something that either blatantly is inside or outside. You wouldn't pick something that might be on a side. So this is an x and a y, and so I'm going to test this in my inequality. So I'm going to put 0 in for y, less than or equal to 2 times 1 squared minus 5 times 1 minus 3. Is 0 less than or equal to, this is going to be 2 minus 5 minus 3. Negative 6. Is 0 less than or equal to negative 6? That is false. And so then in that case, we're going to shade everything outside the parabola. So that's how that works. Okay, so here we're going to use this ability to graph quadratic inequalities to solve a word problem. You're making a photo album. Each album page needs to be able to hold 6 square pictures, if the length of one side of each picture is x, then A is greater than or equal to 6x squared is the area of one album page. So there's the area of a picture, because if one side is x and it's a square, the other side is x. And we're timesing it by 6 because there's 6 pages, or 6 pictures per page. And so to graph this function is the first task. And so A, definitely can be written as y. So y equals, let's just graph that, y equals 6x squared. So if you do your axis of symmetry and it's negative b over 2a, well, there is no b here because this only have an a. So this is going to be 0 over something, which is just going to be 0. And so we're going to start our table at 0. If we put in 0, we're going to get 0. It's going to open up. I'm going to go ahead, I gave me this blank one here, so I'm just going to go ahead and draw in some axes. So we're going to have 0, 0. Then I might do 1. So if I put in 1, I get 6. 2, 3, 4. So there's 1, 6. If I put in negative 1 squared to be 1, I also get 6. Alright, so I'm going to fudge a little here and only do those 3 points. If you wanted another one, you might do like a half or something. Because obviously 2 is not going to fit on that graph, especially if you're counting by ones. And then I want to do a test point again. So maybe my test point is 0, 3. So 0 is my x, 3 is my y. So we're going to test to see is 3 greater than or equal to 6 times 0 squared. Is 3 greater than or equal to 0? That is true. And so in this case, we are shading everything inside the problem. Okay? So then our question we have is, if you have an album page that has an area of 70 square inches, will you be able to accommodate pictures with 3-inch sides? And so that's going to be a y, that's going to be an x, so can I go over to 3? 1, 2, here's 3, and if I go up to 70, is that going to be in this parabola? Well, the deal is I didn't make my parabola big enough. So you really just need to check it in your equation if you didn't make your parabola big enough. So we're going to do 3 squared. So this is 6 times 9. 70 greater than or equal to 54. That works. So will you be able to accommodate them? Yes. Okay, so the next thing we're going to look at is a system of quadratic inequalities. And remember, a system is just 2 or more. So we're going to graph 2 inequalities on the same coordinate plane. And you just want to make sure that you shade the overlapping section darker. Alright, so here's your example for a system of quadratic inequalities. And you're just going to graph them both on the same coordinate plane and shade darker where they overlap. If you have colored pencils, this would be a good time to use those. I'm going to make the top one be red and the bottom one be green. I'm going to start with my axis of symmetry. Remember, if it's just in standard form, that's a good place to start. X is going to equal 0 because there's no b term, there's no x term in the middle here. And so b is 0 and 0 divided by anything is 0. And then when I start my table, I'm just going to start it at 0. It's going to be 0, 9. And I'm going to go ahead and do 1 and negative 1. Remember, you are squaring before you putting in the negative. So this is going to be 8 and 8 and 5 and 5. Alright, and then you want to shade, and so I'm going to go ahead and just use the test point 0, 0. And so then we're going to get 0 is less than or equal to 9. And that is true, and so we're shading on the inside there. Okay, so it's very similar to the first example of this video. We're just doing 2 of them on the same coordinate plane. So then I'm going to look at the other example here. So this is 2.5, negative 2.5. And when I put that into my calculator, I get negative 12.25, which is down here off my graph, which is fine. And I'm going to skip a little bit. I'm going to go ahead, maybe skip to negative 1 and 0. So if I put in a negative 1, I'm at negative 10. And if I put in 0, I'm at negative 6. So then continue my table. I'm going to put in negative 4 and negative 5, I think. Negative 4 is at negative 10. And negative 5 is at negative 6. Okay. So here's my parabola. You do want to make sure you draw it kind of over the whole thing. I didn't do really good on that red one there. Okay, so then I need a test point for the green one, and I'm going to go ahead and use 0, 0 because 0, 0 is going to be on the inside since I went through 0, negative 6. And if I plug in 0, 0, I get 0 is greater than or equal to negative 6, which is also true. So the green one gets shaded on the inside. And then you need to come back and shade darker where they overlap, which is going to be this section in here. Okay, so really the same thing, same principles as when you were doing linear inequalities. This is just now with parabolas. So next we're going to look at solving a quadratic inequality in one variable, and so really your y has turned into a 0. And if you'll notice, we're comparing them then to 0. You're looking at the quadratic is either less than 0 or the quadratic is greater than 0. And notice that that's your y that you've replaced with 0. So what we're going to do is, if we're looking at the first one here, ax squared plus bx plus c is less than 0, we're looking for it to be below the x-axis because that's less than 0y. And if ax squared plus bx plus c is greater than 0, we're looking to see where it's above the x-axis. So let me show you. Okay, so we're going to graph here to solve x squared minus 5x plus 6 is greater than or equal to 0. Okay, and one of the ways is to solve by graphing. So we're first going to graph our parabola. And remember, if it's in standard form, you can do your axis of symmetry, which is I've done so far. But you can also, if it factors, so I'm going to see here if this factors. If it factors, you can do your intercepts. Alright, so let's see here. Positive 6, negative 3, negative 5. Alright. So 2 and 3 then are my intercepts. Okay. Which means that my vertex is going to have an x that is 2.5. And if I plug in 2.5, I'm going to get negative 0.25, so negative 1/4. So here's my parabola. And what you really need to know from this is the intercepts. I mean, so even if you're graphing using axis of symmetry, you have to know your intercepts. All right, so this says x greater than 0. This is 0. The x-axis is 0. So where is x greater than 0? Well, we have right here that it's greater than 0, and we have right here that it's greater than 0. So this is actually an OR statement, if you remember back to our OR statements. So when x is less than or equal to 2, or when x is greater than or equal to 3. And I found those using these intercepts here. So for all these x's that are less than 2, it's going to be above 0. And for all these x's, where x is greater than 3, our graph is going to be above 0. So let's try that again. And this one is not factorable. So I'm going to go ahead and have to use my axis of symmetry to graph it. So we're going to have 11 over 2. So that's 5.5 if you would prefer that. And you really, though, want to know your intercepts. So we're going to hope that we happen upon our intercepts. So this gives us negative 25.25. Okay, so at 5.5, someplace way down yonder. And so I definitely would maybe skip around a little bit. So I'm going to go ahead and go to 3. I'm trying to find my intercepts. So at 3, I'm at negative 19. Okay, so at 0, I'm at 5. So let me go back and do 1. At 1, I'm at negative 5. All right. So this presents a few problems here. So here at 0, I'm up here at 5, but at 1, I'm at negative 5. And if I'm wanting to solve this, I really need to know where it crosses the x-axis. So plan B then needs to be quadratic formula. You have to know where this crosses the x-axis for you to properly give an answer. Alright, so negative b plus or minus b squared minus 4ac all over 2a. So this is going to be a positive 11 plus or minus the square root of negative 11 squared minus 4 times 1 times 5 all over 2. So this is 121 minus 20, which is 101 all over 2. Okay, so that's not going to simplify anymore, I don't think. So I'm just going to come to some decimals just so I can see some decimals. So we're looking at 10.52 and 0.475 or 4.48. Okay, so we're looking at roughly there and 10.52 roughly here. And when you graph this, so that's what it's going to look like. Okay, so we want the values that are less than 0. So we want all of our values that are underneath the x-axis. This is an AND statement because it's between the two intercepts. So we're going to say 11 minus the square root of 101 over 2 is less than or equal to x, which is less than or equal to 11 plus the square root of 101 over 2. So we're saying x is between those two values, and that's what's going to give us a negative y value. Okay, let's do one more because I know these can be kind of odd. All right, so let's just go ahead and let's just start with our quadratic formula, because again, now this time I have a negative a, and let's just go ahead and start with our quadratic formula. So I'm going to write it out, negative b plus or minus the square root b squared minus 4ac all over 2a. So remember, your first step is just to graph these. So there's a positive 9, because I put in negative 9. Square root of negative 9 squared minus 4 times negative 1 times 36 all over negative 2. So this is going to be 81 plus 144 all over negative 2. All right. This turns out nicely to be 15 there. So we're going to do 9 plus 15, which is 24, divided by -2 is -12. And then 9 minus 15 divided by -2 is +3. So I have an x-intercept over here at -12 and an x-intercept over here at 3. Let's see here. Axis of symmetry is going to be halfway between those. Which I think is going to be at -4.5. So I'm putting that into my equation, and I'm going to get 56.25. All right, so it does not matter that it is entirely above the graph, because all I need to know is that it is up there. So when I graph it, oh so nicely here, yes, it's going to look something like that. But what I really need to know is where those intercepts, and then does it open up or down. Okay, so there's my graph, and I'm looking for where is this greater than 0. This is where it is greater than 0. Okay, it's an and statement again because it's between those two endpoints. This time though it's not equal to, so it can't be equal to the endpoints. But we're going to say -12 less than x less than 3. That is your answer. In case you can't read that, there you go. So why don't you see if you can solve one of these? So go ahead and pause the video. Okay, so this is what I got as an answer. I first graphed it. I used the quadratic formula and found the intercepts to be -1.37 and 1.70. Graphed those, then I found my vertex, 1/6 and 7 1/12. So there's my vertex, it opens down. We wanted to answer the question, where is it less than 0? So down here is where we're less than 0. It says an or because they're split onto those two ends. So less than this intercept, which is -1 plus or minus square root of 85 over -6, aka -1.37, and greater than this intercept, which is -1 minus the square root of 85 over -6. All right, so this was an or statement. All right, so there is another way to solve these quadratic inequalities, and that is to find those intercepts. And so you can do them by factoring, square root property, completing the square, or quadratic formula. But find the intercepts and then graph them on a number line instead of graphing them on a coordinate plane. And then so when you graph 2 points on a number line, so you have a number line, you're going to plot 2 points, someplace on that number line. It gives you 3 regions. So there's my 3 regions, and then you need to check all 3 regions to see which one or ones work. So how we do that, first of all, it has to be equal to 0. So if I subtract 3 from both sides, and have 2x squared minus x minus 3 greater than 0. And let's see here, I'm going to see about factoring this one. So if we did 2x and x, and we're going to do 3 and 1, -3, +1, because that gives us -3 plus 2, which is -1. All right, so our intercepts are a +3 halves and a -1. And if we look at this on a number line, let's do 0, -1, -2, 1, 2. And so these intercepts, we're looking at 1.5, and we're looking at -1. And so here's your 3 regions. 1 region, 2 regions, 3 regions. And what you want to do is you want to check a point in each region. So maybe we check -2. So we're going to check it in our original inequality. We're going to see if that's greater than 3. So this is 2 times 4 plus 2, which is 10. Is 10 greater than 3? That's true. So this section works. So then if I check 0, so it'd be 2 times 0 squared minus 0. Okay, so this is going to be 0 minus, so is 0 greater than 3? So that section is false. And then I'm going to check 2. So we're going to have 2 times 2 squared minus 2, which is 4 times 2, which is 8 minus 2, which is 6. Is 6 greater than 3? That is true. So because they're split on the ends, this makes this an OR. Okay, so this would be the same thing. This is opening up. This would be the same thing as if your parabola looked like this and you have those two ends that are above it. So we're going to say x is less than -1 or x is greater than 3/2 or 1 1/2. So let's try that again. So we want it to equal 0. So we're going to go ahead and subtract 4 from both sides. And then again, if you can factor, might try factoring here. Let's do 3x and x. And we're going to put the 4 over here so we can make 12. And we want to make it a positive 12 minus 1 to make 11. And then so x is a positive 1/3 and a negative 4. And so when you plot those, okay, so we're going to plot those, positive 1/3, negative 4, and so you have again your 3 regions, 1 region, 2 regions, 3 regions. And we have to check a point out of each region. So let's just check -5. So we're checking them in our original, just in case we messed up someplace. So it's going to be 25 times 3, which is 75, minus 55, which is 20 less than or equal to 4. So that is false. And then let's go ahead and check 0. You don't have to check a number in the middle. So we're going to have 3 times 0 plus 11 times 0. So is 0 less than or equal to 4? That would be true. And so it always either should be the middle true or the two ends true. And then let's just go ahead and check 2. Just in case you mess up on one, you might want to check all of them. So you get 4 times 3 is 12 plus 22. And so you're going to get 34. Is that less than or equal to 4? And that's false. And so again, this would be the same as you looking at a graph like this. Okay, and we're wanting it to be less than 0, so we're looking at the bottom. And so this is an AND statement because it's between these two. So we want -4 less than or equal to x less than or equal to 1/3. And watch your equal to parts. So let's just try one more. Actually, we're going to do a word problem here. Suppose a study was conducted to test the average reading comprehension of a person X years of age. The study found that the number of points, which is P of X, scored on a reading comprehension test could be modeled by P of X equals -0.017x squared plus 1.9x plus 31 when X is between 5 and 95. Because obviously we aren't asking people less than 5 to read, and there's not really a lot of people greater than 95. At what ages does the average person score greater than 60 points on this test? So if we take the score, which is this formula, and we want to know when they score greater than 60. So I'm solving this for x, and so the two ways you can do it, first of all it has to be equal to 0, is you could graph it, or we can do what we've been doing with a number line. And so if you do this with a number line, first of all I would probably advise the quadratic formula. Just because we have some decimals going on here and it probably is not going to factor really well. So -1.9 plus or minus the square root 1.9 squared minus 4 times -0.017 times -29. all over 2 times negative 0.017. And ideally here, you're just wanting some decimals. So I'm not even going to worry about trying to simplify this. I'm just going to go ahead and get this down to a decimal. If you're entering it all at once into your calculator, be very careful about parentheses. Okay, so I get 18.24 for the positive case and 93.52 for the negative case. And so if I plot those, maybe here's 0. There's one of my points. There's my other point. And so you need to then test to see is it between them or is it outside of them? And I'm going to guess we're assuming it's between them because we're getting a score greater than 60. But you might test, 10, 50, and then 95. And we're going to test those in the original. So I'm going to test 10 first. So a 10-year-old is going to get a score of 48.3, and so that's not greater than 60. A 50-year-old is going to get a score of 83.5, so that would be a true. That is greater than 60. And then a 95-year-old is going to get a score of 58.08, so false. That's not less than 60. So our answer is going to be an and. It's going to be 18.24 less than or equal, well, we'll do less than, not equal to, since it said greater than and not greater than or equal to. Less than 93.52 years old, our age. All right, I know this is new. Remember, we have all of class to work out questions, so what you need to do right now is make sure you have your notes written out, and then come to class so we can clarify things. Okay, have a great day.